cool. So, okay, we'll start with lower bound. Okay. So there are two type of lower bounds first of all. Upper bound and lower bound, that's fine. I'm just talking about lower bound first. Okay. So there is a lower bound that exists as a STL function. Okay. Lower bound. Okay. And there is a lower bound that is attached with set as well. So basically it's there in set class. So set int, okay, say st. So there is something called st dot lower bound as well. Right. So one always use this lower bound with linear data structures. Okay, like you have a sorted array. Okay, instead of binary searching yourself inside the array or vector, right? Just give it to lower bound. So say lower bound of vector dot begin. Okay, vector dot end. It's a complete thing. It's not e and d, b, and whatever x you want to search. Okay, this is how you use the first lower bound. And lower bound returns the first value. Okay, or it returns, it actually returns the position. Okay, position in form of iterator. Okay, actually you might want to go and check that yourself first. Okay, it returns the iterator pointing to the first element in this range that is greater than equal to x. Okay, so that's why it's called lower bound. X is the lower bound. You have to start searching from x. Remember the equal, don't forget the equal. Okay, so it basically returns a iterator. And if you do something like this lower bound of vector dot begin vector dot end comma x minus vector dot begin. Okay, this is a valid operation. Okay, so this basically gives you the index now. Okay, because it can calculate the distance within the iterators. Okay, and again now it depends how the iterators are. Okay, so what is iterator? Iterator is say iterator is a just treat it as a black box right now. Just say that iterator is a data structure that can iterate over other data structures, and you can just do iterator plus plus and it will move forward. So something like if I do auto iterator, C++ has the auto function, okay, is equals to vector dot begin, right? And doing an asterisk of it will print the first value, and you can do it plus plus, then doing asterisk of it gives you the second value. Basically this is vector of 0 first, right? And after plus plus this is vector of 1. But one thing, know about it, don't use it. Okay, why do you want to use it? Why are you wanting to make everything so complicated? Basically we try not to use pointers. Okay, that is why a lot of languages don't have pointers, right? So only use when you actually need it for things like lower bound. So I'll write it as LB. Okay, so I'll write the whole thing again. So LB vector dot begin, okay, vector dot end, and you give x, right? This returns an iterator at some position. Then you subtract it with another iterator, that is vector dot begin. So basically you got the difference, right? And can you visualize that this is difference will actually be the index, right? Because say this is the array, sorted array, right? And you did a lower bound of some values 8, and the only value greater than equal to 8 starts from here, that's 9. So 9, 10, 12, 3, 2, 1. So it returns an iterator here. And if you uh, say this is begin, so if you find the difference between iterator and begin, it will basically give you 3, right? Right, and basically the index is also 3. How? 0, 1, 2, 3. So this is how you can find the index, right? Or if you find the value, right, if you want to find this value, so you can just do dereferences, right? Because what is this? This is an iterator, right? You can just dereference it with asterisk and write lb v dot begin v dot end, right, x. Or you can even store it, right? Say you want both the things, so you can store it as auto it, right? And asterisk of it will give you the value, right? And it minus v dot begin will give you the exact index, right? again, if you're wanting to use something like this, please go and test it again first, or go and read about it. GFG is a really nice place to read about it, right? They have all examples and everything, right? So iterators in general, don't try to use it, right? Whatever data structure it is that you want to traverse over or want to read, always use this for auto x in whatever data structure you have. Okay, it can be a set, it can be a vector, it can be a multi-set, it can be a map, but just remember what is being extracted. In whatever you write here gets extracted, so remember. And in case of map, this gets extracted as a pair. Okay, so if you have something called map of integer to vector int, okay, if you have some weird map like this, right? So x dot first will be an integer, right? X dot first will be an integer here, and x dot second will be a vector, right? So always remember what this extracts, right? And always use this to go over a data structure. Don't use iterators. Don't do auto it is equals to v dot begin plus plus it. No, no need to do that. Don't complicate things, right? So this is something about iterators and how lower bound will return an iterator to you, right? And
Sometimes people use each, uh, something like each
each
bracket something.
each is just a macro. So
Yeah.
basically, even I use each. So basically, I read this as each x of a, x of ds.
Oh,
Basically, it's each is nothing. Each is just a macro. This is just the short form of macro. So actually, you can even define it like this. So if you know p processor directives in C++, so you can use hash define each x comma ds as, and in front of this you can just write this for auto x in ds. So basically, you're just shrinking it. But don't try not to use macros right now, okay, unless you have firm grasp on what you're actually doing or what the macro actually does. Or even if you're using macro, make your own macros. Okay, don't use someone else's macro. Okay, it's like cloning someone's git repository and trying to understand what they're doing, right, under the hood, which you'll never understand, right? It's better to make your own macro always. Even if you're trying to use someone's, go and read about it, go and test it completely, right? But better right now, don't use macro. Okay, there'll be times when using macro will be useful, but not right now. Okay, but if you want, you can use very simple macros like hash define uh, vt as vector, right? Just to save some time. Hash define uh, lb as lower bound, right? But right now it's not necessary in learning. This is like something very specific to competitive programming, right? When you need a lot of speed. Right now you don't need a lot of speed, not to worry, right? Even in OAs, of course, you cannot use templates, right? Or predefined snippets. So what's the point of using a macro there? Basically typing the same thing twice. So okay, so this was lower bound, and remember that lower bound returns an iterator to the first element which is greater than equal to x. Remember, greater than equal to. If you're trying to find an element which is greater than x, always lower bound x plus 1. Okay, so that it returns. So basically, greater than x is greater than equal to x plus 1, right? So lower bound x plus 1 if you're trying to find greater than x, right? Lower bound x if you're trying to find greater than equal to x, right? Okay, so with this done, okay, now what upper bound does is there's a very slight change in lower bound and upper bound, and basically 99% of times you'll be just using lower bound. I don't remember using upper bound any time. Okay, that I had to use upper bound. Maybe I did some different workaround, even if upper bound was a better option there, right? So what happens is if you do a lower bound for 3, okay, 3 is the value in this array, 1 2 3 3 3 4, basically you'll get this result, right? This is the first value which is greater than equal to 3, but upper bound will give you this value. That's the only difference, right? Basically, when you try to implement your own binary search, you have to give a condition on what happens when the element is equal. Okay, whether the right moves or the left moves. Okay, so basically in lower bound the right shrinks. Okay, right shrinks so that the pointer remains over here somewhere near. Okay, so what happens? See, say you started here, you came here itself. So you say, okay, right, you shrink. Okay, I'm doing a binary search. Okay, just try to visualize this left and right. So mid is equal to what you are searching for. So instead of left shrinking, you told the right to shrink. So right comes somewhere here. Then again, say the mid goes here. So anyway, this is going to around be the first value that you're searching for, or the first occurrence of the value that you're searching for. Okay. Even if you want to treat it as a black box, you can just understand this as this will be lower bound and this will be upper bound. Okay. Now, how upper bound works actually under the hood is that when you binary search, when the number that you are over right now is equal to what you are searching, the left shrinks. Okay, that's the only difference. So that's why the mid moves here and ultimately ends up here, right? You can try implementing both of those, implement upper bound, implement lower bound. Okay, I think I'll again ask you to do it in binary search anyway, right? And then you'll understand what happens when it's equal. Remember, that is a very uh, important, okay, case. uh, Even in solving binary search problems, actually you won't face a lot of problems searching binary search problems, but to understand how the equal works, or where to put equal, where not to put equal, okay, that is a big thing, right? Sometimes it might make a difference in solving and not solving a problem, right? So don't worry about upper bound so much, right? Just know what lower bound is, greater than equal to x, right? Now, okay, we talked about arrays, lower bound, right? Set's lower bound is, and why do you think set has a different lower bound? Okay, then for that you have to understand what set is under the hood, or what map is under the hood. Even map has a lower bound. Okay, but generally we use lower bound with set mostly due to the kind of problems you get, and those are basically solved by set lower bound. Okay, so always remember that set and map are not linear data structures. Okay, always remember that. So if you have a iterator of a set, okay, somehow you have a iterator of a set it, you cannot do it plus plus. It's not linear. Okay, it's not at all linear, so you cannot do this, right? Actually I have to read about it, right? But basically this is not how it works. Okay, because set and map are based are actually a binary tree under a hood. Okay, it's called balanced binary tree. Okay, and mostly not just binary tree, it's a balanced binary search tree. So if you know a bit about binary search tree, it'll be something like the values will be spread like this: left child is smaller, right child is bigger, right? And this goes on. And also the fact that they are balanced. Okay, so the tree won't look skewed like 10, 9, 8, 7. No, it will always be balanced. Okay, something like 8, 9, 10, 7, right? And there are two types of balanced binary trees. One is AVL tree, one is red black tree. You don't need to know the details, not at all. Okay, just know that they are binary trees, right? And their way of balancing is different. Okay, how they balance is different. If you want to know, you can just read about a bit how AVL balances it. The two subtrees height shouldn't be greater than 1. So here the subtree height is something, here the subtree height is something, but you see they are not, the difference is not more than 1, right? I'm not going to a lot of detail for now, just you can treat it as a black box. And then there is red black tree. So anyway, if you have solved any problem or have known about binary tree in general, you will realize that they are not stored linearly, right? You use pointers to store them, right? So parent, left child, right child, right? So basically you do use pointers. So basically you cannot do a plus plus and go over the next node, right? Where do you have to go? If you have parent, I tell you to do a plus plus, you'll ask what is plus plus, here or here, right? Based on value, yes, you can guess, right? But this is not how it works. So even if you want to traverse these, you use the same thing actually. Okay, use the same thing. Now even I don't know how it traverses under the hood. Okay, and whether the plus plus thing holds here or not. Okay, but this is the safest bet to traverse it, and I don't think you will have a need to use anything other than this anyway. Now the only other place where you get a iterator of these data structures is lower bound again. Okay, and their iterator is called something different. radial iterators or something. I don't remember correctly. Okay, but remember those are all linear. So again, you cannot move front and back so easily with those. Okay, so the only thing you will be doing or you will want to do is just dereference them. So something like set dot lower bound. Okay, and because you're using it over a set, you don't need to define the begin and end rate, of course, because you're doing it over a set. So you just give a value and asterisk. Okay, of course, again, this is the iterator, and when you dereference it, it gives you the value. So basically, if you are storing something like 1, 3, 5, 9, 12 in the set, and you do a set dot lower bound 8 and asterisk it, you are going to get 9, right? As easy as that. If you have 8, again you're going to get 8 because this gives you again greater than equal to x, right? So that's the only difference. Works exactly the same. You don't even have to worry. Okay, all you need to know is this is used with the set, and one is just used lower bound and begin and end and the value. Okay, that's the only difference. But again, after you use it like 10 15 times in different kind of questions, you will always remember it, right? And with map, we usually never have to use a lower bound. Okay, I don't remember solving. I've seen people solving problem with map dot lower bound, but I have never solved it like that. Okay, I've never seen seen a question where that was required. Okay, but again,
Uh,
yeah,
Manas, one question I had regarding maps is that in C++, default maps are always sorted, right?
map is sorted. Yes, there are two types of maps in set that you might know.
And
Unsorted.
unordered and
Yes,
ordered, right?
yes, yes,
Yeah, so default map will always be sorted, right?
yes,
Sets are sorted, that I know, but map is also always sorted, right?
yes.
Okay.
Yeah, cool. And that is a very important property of map, that it is always sorted. We will see this in line sweep. Okay, there is this topic I've put, I think, somewhere close to map, and it is this property of map is so powerful that this line sweep problems, you can just code it with map in like 2 3 lines, because whatever line sweep does is what map is doing already. Okay, we'll see it then. Map and line sweep problem was there in Zomato way, right? And this was a problem that I have seen
Also,
earlier. Huh?
so one question I had regarding maps was, so if the map is sorted using its key values by default, let's say if I want to sort the map using the values, not so I should not have said key values, my bad. If it is sorted using the keys,
Hmm.
if I want to sort the map using the values, I'll have to use a custom comparator, right?
Don't try to do it. If you want to do something like this, use an array, okay, or a vector.
Okay,
There are ways to feed it with custom comparators, but people don't do it usually because I have tried doing it, but its syntax never fits. I don't know why. And
okay.
you cannot use
Yeah,
it.
that's the
Yes,
yeah, well, that's the issue I've been facing as well. Like when I try to sort a map with a custom comparator, it rarely works.
yes, exactly, exactly. Don't try to do it. Okay. Uh, yeah, there are some problems where you need priority queue and you need a custom comparator for this, right? So there are tricks to do that and not to feed it with a custom comparator, because the syntax never works. I've tried it. With set, you have to use something like DECL type. Then in the
Yeah, yeah,
bracket, you have to pass a CMP or something. And even this should be a particular type of class, okay, or a struct that I was never able to figure out. Okay, I have
I think it
tried.
should be a lambda function. I
Okay,
tried sorting a map using DCL type, and it worked when CMP was a lambda function defined in the same function that it is.
okay, okay, okay. But do not rely on that, because that is not something that you'll be using always, right? And
Okay.
yeah,
Okay.
you can never guarantee like it works like that exactly. So better ignore it, okay, and try to. There are other ways to do the same thing, right? I don't think in any problem I found that doing this was absolute necessary to solve the problem, right?
Understood.
Cool. So again, yeah. So we're talking about the property of map, right? Okay, we'll see that in line sweep. Okay, another thing is that mm, anything particular with set. Again, remember that set cannot store duplicates, right? So say you have a problem of uh, actually we'll talk about it during sliding window, but I'll just give you a small brief by like why do you use multi-set, right? Please forget about multi-map. Okay, there might be some uses. Okay, there might, I'm not telling you there are no uses, there might be uses, but I have never found a problem where again it was absolute necessary to use that. Okay, so it's better you forget about that for now. Right, I have seen a lot of people using this, but in CP I have never seen anyone using it. Right, give me 1 second.
Okay.
Yeah.
So it's not usually required, right?
No, not usually required. You don't have to go to multimap. Any problem you
Okay.
feel you have to go to multimap, tell me, I'll tell you an alternate answer to that. Right. I have never
Okay.
studied this very deeply. But multi-set is something that you'll require in some places. Okay. So, and multi-set is a rather not a very straightforward data structure. Okay. Using it is not so straightforward like sets and maps. Right. So, okay, multi-set does is it's like a set, so it will store everything in order. Right. But it will also store the duplicates. Right. Give me 1 second. I'll give my attendance. Sorry. Yeah. So what multiset does is it stores the duplicates as well. Right. So this is how a multiset will look. Okay. I call it MST. It's not a minimum spanning tree. It's multiset, and this is set. And again, this is one thing you should go and read about first. Okay. Because see, how I do is I try to use one or two functions in data structure, and if it doesn't work the way I want it to work, I immediately stop and try to find an alternate way, and I stick to that. Okay. So if you are trying to do something like mst.erase a value, okay, if you do set.erase, it's perfectly fine, right? You can always erase, say, second value, erase 2, and it will erase this value, right? But if you're trying to do mst.erase, this you have to check what it does. It erase both the instances. Okay, it will find all the values and it will erase it. Okay, so this is something that you don't want. Please go and check it. I have never used this. Okay, because it has something, it doesn't work the way I want it to be. Okay, so this is the only other case where I use iterators. Okay, so what you have to do is you have to do something like auto it is equals to mst.find 2. Okay, and of course it is one single iterator, so it will find one single instance of 2. Okay, okay, right now it doesn't matter where the instance is. It doesn't matter because it's not ordered anyway. Right, I mean it's ordered, but like the ordering doesn't matter if you remove this 2 or that 2 is what I'm saying. And then you can do mst dot erase iterator. So basically it will delete whatever 2 this is pointing. So this will just delete one single instance. Okay, just remember this about multi-set. Okay, this is how you delete in multi-set. Okay, there are 2 operations that is required. Okay, do not try to use that. Okay, again I want you to go and confirm it, why this is bad or why this doesn't work as intended, because I have tried using it and I've ran into a lot of problems. Then I just stick to this. Okay, now with set you can use this very easily, you don't have to worry. So this is a value, and this what I'm passing here is an this what I'm passing here is an iterator. Okay, even here you can pass an iterator, but why do you want to complicate things again? Right, so this is how you use a multi-set and a set. Insertion is simple, mst.insert, set.insert, right, same. Now I'll just give you one small use case. I'll just give you some briefing about it, like where do you use it. So multi-set is basically used to find sliding window minimum. Okay, now what's wrong with using set is that, say you have 1 2 4 2 3 9 6 and your window size is 3. Okay, now let's say I'm using set. So I read this window first and it has 1 2 4. Cool. How you query the smallest element set? Just do st.begin, again is an iterator, right? And begin, the first value in the set will be the smallest value. You dereference it and you get the smallest value in the set, right? This is how you get the smallest value in set. Right, you dereference the first iterator or the iterator that points to the first element of the set and you get the smallest value in set. Okay, now, okay, this is fine, you got 1. Okay, cool. Windows minimum. Okay, now you shrunk this window from here. Basically you said set.erase 1, and you increment the window here, you did set dot insert 2. Now your set looks like 2 4, right? Again you take the minimum, it's 2, perfect. Now see what happens. You shrunk the window. Basically you said set dot erase 2. What happens? It erases 2 from here. But is really 2 erased? No, it's still in the window, right? And then you go and write 3, right? So now your set says I just have 3 and 4, but basically you have 2 as well, but you just erased it, right? So here is where you need duplicates in the set, because right now this windows minimum according to your set is 3, which is not, because it's 2, right? So in this case use multiset, right? So had you been using multiset, right now your input would look something like sorry, your MST will look something like 2 2 and 4, right? And when you're shrinking the window now, what do you do is mst dot find it, auto it is equals to mst dot find 2, basically pointing to any of these, doesn't matter, say this. Then you do mst dot erase mst dot erase it. Okay, so it removes that instance of 2, this particular, any particular instance of 2. Then mst dot insert 3, so it makes it 2 3 4, right? And this is exactly how you wanted it, right? And even here you can use the begin to get the smallest value, basically mst dot begin, right? So this is where you will require MST to find sliding window minimums, right? And I have a problem of sliding window minimum in sheet in 2 pointers, I think. So you'll find it, and you'll I hope you realize like why is MST used overset in certain problems, right? Just to handle duplicates. And remember how you delete elements from MST. Okay, multi-set. Okay, you don't do direct erase. Do this. Try direct erase. See what happens. Okay, check it out yourself.
So
Yeah.
in this case, why don't we use a priority queue over a multi-set?
Mm, see, as far as I know, priority queues are slower. First of all, I don't know how it compares to multi-set though, right? But yeah, you can use a. Oh wait, how will you remove an element from priority queue?
Oh yeah, never mind. Yeah, the top, yeah,
Yeah, you
okay.
can always remove the
Last element.
top, right?
It's
Yeah.
always the last element from. Yeah, okay.
Yes, yes.
But we can still refer to the first element, right? But then removing the element is a difficult
It's not.
part. Understood
Yeah, it's
after
not
it's
necessary that
sorted.
you. Yeah, basically you
Uh,
will take the complete window time then n into d, right? D,
yeah.
say d is the size of window, right? Here you are basically just taking n into 2 times log of window size, and you can even remove the 2 if you want, right?
Yes. Understood.
Yeah, cool. So this was set and multi-set, right? Map is pretty straightforward, right? You can make map of whatever to whatever. You can make map of map. Okay, this is the power of STL class. You can make whatever to whatever. Okay, so these are templates. You can make your own template as well, right? So uh, okay, any again, I'll just repeat this again. So every time you go over a map, auto x in map, every time you do this, remember x is a pair. It is always a pair, not an array, not a two element array, nothing. It's just a pair. And x dot first represents this part, and x dot second represents the other part, right? And you will treat these variables x dot first and x dot second as you treat these data type. If this is a vector, you can always traverse over it for auto y in x dot second. You can always traverse it like this, right? You treat it how it is. If this is a pair again second, so you can always write x dot second dot first or x dot second again, right? Just treat it as the same data type. Apart from this, yeah, apart from this, there is one more property of map, and for this you have to listen carefully, right? So what happens is, for map, a value of 0 is also a value. Okay, always remember that. A value of 0 doesn't mean that you have removed that entry from it. So what I mean to say, it's say map of 4 is 0. Okay, say, and map of 5 is 1. Right. Now, what should be the output of this map dot size?
2, right?
Yes, it will be 2. Remember. Now, when I'm talking about it, it seems obvious, right? But again, you can use map in place of multiset as well. Again, right now, I'll solve the same problem. Okay, using a map now. 1, 2, 4, 2, 3, 9, 6. A friend of mine taught me this actually. Before I was just using multisets. So there's something called map.erase, just like set.erase, right? And again, map stores unique values, right? Map of x will always point to that value, it won't make a new copy, right? So you can freely erase using the value itself. So what you can do is, again, you push map of 1 plus plus, okay? So map of 2 plus plus, map of 4 plus plus for a window. For this particular window, say again window size is 3. So your map will look something like 1 1 2 1 4 1, right? This is your map. Key and value can be the count of that element. Okay, now it's really easy to see that if you go one window forward, you will have something like 1 0 2 2 4 1, right? Now remember that if you do something like map dot begin, right, firstly remember that this will return a pair, it's not returning a value. And what is the pair? This and this, key and value. So you have to do something like this dot first, right, to get the key. And key is the element's value here, and value is what you are storing is the count, right? So if you do this in this map, you are going to get 1, okay, which you do not want, right? What you want is 2 here, right? So what we are going to do is, every time the count of a number becomes 0, so when you are shrinking the window from here, you see that map of 1 is now 0. You basically just erase it from the map, that's all. And I think this is far easier than using multiset. Okay, you erase it from the map. So this map technically removes this part, right? So your map will look like 2 has a frequency of 2, 4 has a frequency of 1. And on querying map.begin dot first, okay. Or see, if you have like if you're not comfortable with that, you can always do something like pair intent, or I think that is easier. Let's see. Okay, again, what does map dot begin give you? Gives you an iterator. Asterisk dereferences gives you a pair. So if you're not sure how to use it, always do auto it is equals to this. Now you can realize that this is a pair of intent. Why? Because every entry is a map is a pair, and pair of xy anything. Okay, now it it's not an iterator, so you can maybe this will mislead. So maybe you can say p, okay, and then you can use p dot first and p dot second, right? This will give you the first value and first value of the pair of first value of map. Okay, basically this will give you p will be equal to 1 comma 0 from the example, and p dot first will be 1, right? And this is the example here, 1 0, right? So again see this, when the value becomes 0, you remove it from the map, right? Because map counts 0 as a valid value. Okay, it won't remove the entry from the map, so you need to have this. Now again, if you shrink the boundary of 2, you just make it 1, and because 1 is a valid frequency, it's not 0, you keep it there. Then you add 3, right? So basically this is your window right now, 3, so this becomes 2 3 1, and then you get 2 as the minimum, right? So this fixes what set was unable to do. Okay, it eliminates the drawback of set here, and without using a multi set as well, right? But again, you will still find uses of multi set elsewhere as well, right? But again, if you are smart enough, you can always use map, or always substitute multi set for a map. Okay, let's see if we come across such problems, we will see how to do that, right? But I hope map, set, multiset, all their functions, useful functions are clear. Right. Again, this is a bit confusing, this part. Remember that whatever value of map you're trying to extract will always be a pair. Then you have to, if it's an iterator, you have to dereference it. After that, you get whatever type it is. Right. Then you always have to do first and second. Now, what is first and what is second depends on how you create the map, but first and second will always be there. Every entry of map is a pair. Pair of what is upon you. How you store your map, this and this. Right. I hope data structures are at least clear. Right. STL data structures. Because how to use them is an essential thing. Right. I'll briefly talk about count function now. Okay. Now again, just like you have lower bound of this x and set dot lower bound of x. Similarly, you have count function as well. Okay, and find function also. Very similarly. Exactly same. So if you want to find something in an array, what do you do? Find array dot begin, array dot end, value. Right? If you want to count array dot begin, array dot end, or vector dot begin, vector dot end, value. Right? Similarly, set dot count x will give you the count of values in set, which is always going to be 1 or 0 either way, right? Or set dot find x, right? But basically we try not to use the find. Okay, again, because this might end up giving you an end, so you have to put an additional check where set dot find is not set dot end, then you dereference it, because if you try to dereference the end, it will give you either an error or a garbage value. Okay, so basically if you want to forget about this, just forget about this. Okay, if you are not understanding, or if you don't want to know about this, fine, just leave. Just remember count function. Right. So in the set we don't care where the value is right now. Okay, we just care about its presence. So instead of doing find, you can use count. Right. If the value exists in set, it will return a count of 1. Right. If it doesn't, it returns a count of 0. Right. And basically this is false and this is true. Right, in C++. So basically you can directly use it inside a if function. Instead of doing if set dot find some value is not equal to set dot end, you can just do if set dot count x. That's all. It's that simple. Right. It shortens the code as well and shortens how you think about it as well. Right. Similarly, you can do whatever count you want, even inside array, like count. Mostly it's used with strings. It says that count string dot begin, string dot end, and you count a particular character inside it, like say a. Right. Or a very good use of it, as I already talked about, was you can check for vowels, or say even you have a greater range than vowels, say string of some set of characters, some k characters that you want to check. You just embed all of them in a string. Say it's not just a, e, i, o, u. Okay, it's some other characters as well. So instead of checking each and everything from here, like earlier we used to do this, right? If vowel check is there, we do if ch is double equal to a, or ch is double equal to e, or, and we keep on doing it, right? So instead of doing all that, you can just do if count k dot begin, k dot end, and whatever character you are trying to match. Okay, just you can just write this, right? And what is the maximum count that will return? Again, this looks like a set, right? I've just put the search keywords once, search characters just once here. So basically it's just going to return 0 or 1, right? Basically being false or true, right? So remember this hack, right? Instead of searching for each and everything, you can just embed whatever you want to search inside a string and just search this complete thing, right? So this is the use of count function, right? Cool. Again, there are 2-3 functions more, but I'll just go through the Discord chat. What do you want to know? Iterators and vectors, that I told you about. Shortcut tricks. See, tricks is something that I cannot always remember on top of my head, but as I'm talking about data structures, I am telling you small little tricks, right? As I talk about more, I'll tell you more. CP overcame using STL. Uh, Hidden gems of STL. What problems I face in CP? STL, see, basically, STL solves a lot of problems that you don't even know. Okay, so multi-set solved the problem of minimum of a sliding window, right? Again, this map erase solved the complexity of MST. MST is a lot slower actually, right? So using map is a lot faster than MST. So try to prioritize that. But if you don't understand how use the map, use MST, right? Apart from that, not exactly like something problem that face. Initially, I was also facing problem with iterators. Okay, but the trick to use iterators is to avoid them. Okay, as much as possible. Okay, every time you use lower bound on vectors, subtract it with vector dot begin to get the exact index. Use the index, right? Things like that. Okay, apart from that, hidden gems. Yeah, let them be hidden for now until we find them. Confusion function is the one implementation I'm going to do is like finding character in strings differ. We use find and string dot find. Yes, 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 yes. String dot find. Mm, avoid that. Use this find or count for string. And I think string dot find tries to find a substring in a string. Do that manually, please. Don't rely on STL for each and every single thing. And maybe if you don't know how it works, then totally don't use it. If you can code it directly, say even count, you can code it directly, right? So only if you rely on this function, have used it multiple times, only then use it. Otherwise, how much time does it take to write a count function? Okay, or maybe counting something, whatever you want to count, right? Later you'll see you'll just use DP or something to count that anyway, right? As you go further, right, you won't be using a lot of STL because a lot of things have to be pre-calculated or done in some other tricky way, not tricky way, like using tricks such that you do not do the brute force counting everywhere, right? So that for that, of course, you can use STL, right? For that you have to use some tricks, some dynamic programming here and there, right? So then you'll realize that right now whatever you're trying to learn or you're trying to find some magic inside STL, that won't work later, right? But yes, knowing everything is good, right? Again, Rishabh wrote, accordingly lower bound and upper bound have different implementation methods for sets and maps. Okay, I talked about that exactly, right? Upper bound is something that you don't need to use most of the time, right? Actually never, so don't worry about that. Keaton has asked everything. Understand when to use multi-maps, multi-sets, leave multi-sets, leave multi-maps, multi-sets I talked about. Cool. Okay, apart from this, I'll talk about something else. Uh, like I taught you merge sort, right? So in merge sort there was the merging part, right? Where given two sorted array, you merge it into a single big array which is also sorted, right? So you have a function for this actually. So say this is A and this is B. Okay, and in merge sort, of course, there won't be A and B. This will be some. Actually, I'll write it that way. This will be A dot begin. Right. Let's say is the last two array, and how else can you use it? Or how you can manipulate the indices? You can decide it. It's not so hard. And this is something A dot begin plus mid. Right. Or yeah, mid or mid plus one, whatever offset of one. Take care of that. Right. And this is A dot end. Now, exactly how the one offset works, I'll tell you right now, but I'll just give you a general idea once. Right. So basically, you have to say where merge. It takes 5 parameters. What, what is the beginning of first array, end of first array, beginning of second array, end of second array, and beginning of from where you want to insert it inside a back inserter. Okay. I have not read about what back inserters are. Okay, but basically you have to feed where it starts. Okay, I actually have a snippet around it. Okay, actually again you don't need it because right now I think it's you guys are better off not knowing the tricks because then you'll avoid implementing it yourself, which I don't want. Okay, but just because you know it, I'm telling you. Okay, but do not try to hack into something. Okay, to like don't be lazy, try to do things yourself, right? Unless and until it's something that you know completely, and it's a waste of time writing it yourself. Then only do something like that. But mostly I'll ask you to code most of the things, but things like count and find and those things like that, you can always linear search, count, or linearly just find it there, right? So that I won't ask you to do it yourself, but things like merging and all, please try to do it yourself. Okay, so sort tree, begin end and back inserter. Okay, so again I'll ask you to go and GFG this, okay, and read about it, right? Or basically don't try to use it so much, okay? I don't think you'll be using it anywhere else. Cool. But apart from that, it again goes like that, start and end. So basically say a and b is merging into c, so basically you just write a dot begin, a dot end, b dot begin, b dot end, right? And you give back inserter of, okay, I think you have to give the complete array here. Okay, so it's basically back inserter. Yes, you have to give the complete array inside it. So back inserter of c. So merge. Again, just to let you know, otherwise it's not something too very important. Just to let you know that you can do it in STL like this. Again, there is something called partial sum. Okay, now this is very interesting, and this gets useful after a certain time. So partial sum, if you guys know it, what prefix sum is, it builds the prefix sum. Okay, so it takes the array whose prefix sum you have to build from start, end, and the starting index from where the prefix sum has to be copied. Right, now remember, this doesn't take an end parameter of the second. This is basically like a dot begin, a dot end, and b dot begin. So what it does, it does b dot begin, it copies with a dot begin, then goes to next position in both a and b, copies that and adds it. It constructs a prefix sum basically. If you know what prefix sum is, you'll understand this. So it constructs a prefix sum in b's position. So basically if you have 1 2 3 in a and you pass this a dot begin, a dot end, b dot begin, so in b, also remember that b has to be allocated, I guess. So b has to be given a space, so vector int b of whatever space n you have. Okay, so in b it will create something like 136, right? And if you want it to create prefix sum in a itself, okay, so you can be a little smart and you can here instead of b just give a dot begin, right? So partial sum, a dot begin, a dot end, a dot begin again. So it's, you are asking C++ to call partial sum on a array starting with a's first index itself. So it will create prefix sum over itself. Basically a will be a prefix sum of itself, right? So this is one thing. Again, right now it's not so useful, and it takes zero time to actually. It will be faster for you to write, like manually create prefix sum than to use this, right? But again, this is available, right? Apart from this, what I have used, to be honest, the most important function that I have used in C plus STL from STL library, apart from data structures, is set lower bound. Okay, you'll use that a lot. Okay, because you have to find something, and how you efficiently find is you efficiently store it in set, right? So if you know how to use it, that's all fine. And set dot count or any count, right? Apart from that, I don't remember using something so very much, right? Lower bound is something that you should know, that it's greater than equal to x, and how do you do tricks around it. Okay, one trick was like how to find a number not equal to x but greater than x. So basically you just lower bound on x plus 1, that's all, right? That's a simple trick. Okay, now, yeah, this is one last trick, and I think after this I'll just take your queries, whatever you want to ask. because I've told almost everything. Okay, what do you want to how do you do this? You want to find numbers not greater but less than, right, in lower bound. So 1 2 4 6 8, a lower bound, not a lower bound, whatever function of over this set of 3 should return 2. This will also happen, right, where you have to find, I think I solved a question where you have to find one value like greater than equal to on both sides. Okay, so basically for 3 and sorry, not even equal to, greater than on both sides. So for 3 it should return something like 2 comma 4. For 4 it should return 2 comma 6. Okay, for 6 it should return 4 comma 8. You have to do it in log n time. You can very easily do it with lower bound. Think. One thing is that 4 6 8 is really easy, right? You lower bound on 3 plus 1, 4 plus 1, 6 plus 1, right? Just tell me how to do the smaller one. So I'll just remove that for now. Any ideas? How do you reverse the trend without changing the comparator? This is small little tricks that I want you to know. Instead of changing the comparator, okay, and instead of changing how you do things, how can you manipulate something to do something like this? Always don't think about algorithms, okay, or data structures. Think about how you can manipulate the data as well. There'll be a lot of places where you need to manipulate the data. Like, I'll give you an example. There will be a question where the range of values are like 10 raised to the power 9, right, and values are 1 1000 this and 10 raised to the power 9. But the thing is, you don't care about the relative difference of them, right, but you want to have them accessible in constant time. Not like that, you want to index them in constant time, so you can normalize this and write it as 1 2 3, because the relative difference doesn't matter in that question. Again, it depends from question to question, but this is an example that I'm telling you. Okay, so you can normalize this like that, and if you can see, you can quickly access them as, you can write those as a of 1, a of 2, a of 3, right? Now again, it depends like what the problem was asking, but there was a problem where you had to normalize the data into this, and then you can use this very efficiently. Okay, back to the original problem. Maybe I'll just remove this. If you didn't understand, it's fine. I'm just telling you, you can also manipulate the data. Okay, no idea? Cool, I'll tell you. Okay, store it as negative values. -4, -6, -8. Now tell me, what is the lower bound of -3 plus 1, basically -2? Okay, I wrote it wrongly. If you change the sign, what other thing happens is the trend reverses, right? It's -8, -6, -4, -2, -1. So if you want to find, and again remember, this is a different set. Okay, we made a set out of just negative values. Okay, now if you want to find a smaller value than 3, what I'll do, I'll first negate it, I'll add 1, then I'll lower bound on this set, which will return me -2. I'll again negate it back and I'll get 2. Right, try it for any other number. You want a number less than 5, 5. You did a -5, you did a +1, and -4, right? So basically -4 will directly fetch you 4, -4, sorry. Then you negate it, you get a 4, right? And this was our aim, right? Initially we were given 5, and what if we found a number less than 5, that was 4, right? And for this case we were given 3, we found a number less than 3, that's 2, right? So if you understand, you can even manipulate the values instead of manipulating or trying to change something in algorithm. You can directly manipulate the values. This happens in priority queue as well. If you want to change the order, negate the values and insert it, right? When you want to use it, negate it back. Cool. Anything else that I missed or you want to know about? because as far as I know, I didn't teach you anything magic. I just taught few more things about the same data structure or how you can use it, which you would have eventually explored while solving problems. But this will at least broaden your horizon and know what you can search for a particular data structure when solving problems, or how you use certain data structures. Hmm. What is data structure? So what all things are there? Hmm. Again, in STL library, there is something called PVDS, right? This is a very big advantage for C++, right? I'll just tell you very briefly what this is, right? And this is actually the hidden gem that Kirtan was trying to ask. Okay, and PVDS is a set. Okay, it's a set, exactly a set. But there's one thing extra. It's an ordered set. Okay, you know the order of elements as well. Okay, now what ordered set means exactly is I'll explain you. Right, there's a very good code forces article on PBDS and how to use it. How to use PBDS is there's actually a very big template around it, and you actually in Windows you have to change a file to use it. The library is has some weird dot extension on it. It's some HPP with 000, I don't know what numbers. So this you have to delete it so that it just becomes HPP. Then you'll be able to use it. Okay, maybe I'll share the exact template how to use it in the same channel. Okay, in the same thread. So leaving aside anything, everything, you can make it. You can type def it into if you. I hope you know what type def is, and we use a hash and type def something into something. You can do it like that, right? So you can use a different type totally, right? Okay, I'll send the complete snippet for this, right? But not right now because you won't be using it. Just know what it is, right? And I don't want to use it right now. I tried to use this in one of my interviews and they just straight away said no. Okay, so what ordered set is that say you have mm, values in a set. Okay, 1 2 5 9 13. Now you can ask there is a separate function in this called order of key. Okay, so basically order of key returns you what will be the order of x if you try to insert it here. So if x was something between 5 and 9, it will return 3. It was something between 9 and 13, it will return 4. Here it will return 2, here it will return 1, here it will return 0. Okay, or basically you can say how many elements are smaller than this, right? I think it ignores the uh, equal part, and there is a way to actually make it store duplicates as well, right? But that is some trick that you won't require, right? So it returns the order of key, and you can also do something like find by order, right? So you can do find by order, and this is very useful if you want to find some median of the array or the set. Say you know set is of size 5. If you find the third element, right, that will be the median, right? So you can just do find by order 3, right? So it gives you this two functions. Okay, and if you think that you'll realize that set doesn't offer anything like this, right? And this has advantages in certain places, say counting inversions, right? So in counting inversions you can get like how many numbers are smaller or greater than this, right? Something like that, and then you can quickly add inversions, right, instead of doing the merge sort. So this is the only other way of counting inversions, and PBDS is actually useful at a lot of other problems as well. A lot of interval problems of sort I've seen PBDS being very well used, right? uh, some problem like how many actually there was a code for this problem, but leave actually. I'll just making this more harder. Okay, because technically you won't be using PBDS anywhere right now, or I won't try to give you a PBDS problem. I'm just telling you something like this exists. Okay, and try not to use PBDS anywhere else as well, but I'm just telling you it exists. Okay, and there's a whole big boilerplate to call this, right? Alright, apart from this, if you want to ask anything. That's all. Let me think if I left something. I think that's all. If I get to any other tricks or something that I want to share, I'll let you know. Right. Cool. If you have no queries, you can leave. It's already 10.